Griffin's occasional series in YouTube tutorials. Today I've taken this from Brett Cholson, and there's the problem there. This person commented on the 15th of September, and we want to look at count these guys. Now, not quite too sure whether this person that wrote in just wanted the blue ones or these, and when I ran this, could only get the blue ones, and the problem is that this color here and this color here are quite similar, and when we do the image processing, we can only end up with this. So just to say, the intellectual property belongs to Brett. You can see it all there. I've taken some of the bits out. His answer would be the more complete one, but I'm going to explain what's going on. So I have it there. And just to say before I start, sorry for jumping, I did color segmentation myself sometime in 2011, and if I can just jump on a little bit, in this one here I was trying to pick out the red, so you can just about see there's a red coat, there's the red coach, and there's another red coat, and you see I've picked it up there. So I've done this already, but this is just another version of it, so I'll just shut that down just so okay, and I published a file, so there we are. So if you just look at that screen there, so I've done my tidying up. I formatted to long to 10 decimal places or 12 or whatever. Font size is 20. I've read in the image, and we're doing subplots. So we'll just go on a little bit. So there's the original color image. So we're trying to pick out these ones. I only end up picking out the dark blues. Okay. So we're going to use adaptive histogram. So we want to try and tidy it up. So just go back here a sec. We've stripped out from the RGB image, we've stripped out the red channel, the green channel, and the blue channel, and we're going to run the adaptive histogram equalization on each separate channel. That we've done there, adaptive histogram equalization. Okay, and then on this line here we use the cat command, so we're combining the three separate channels back into one file. Remember, layer 1 is red, layer 2 is green, and layer 3 is blue. And then, so we've tidied it up, we've done the histogram equalization, the adaptive histogram equalization, and now the fun starts. So we convert it to grayscale. There's a bit of noise knocking around, so medfill2 is median filter into 2 dimensions, and we're using the size of our median filters of 15 by 15. Now you'll probably have to play around with this yourselves. It could be 9 by 9, it could be 7 by 7. I just left Brett's original figures in, and then we do a subplot, and we'll have a look at the image here. And just so with that, then we do the histogram of the grayscale image, and then I'll get back to the binarization. So let's just go down here. So there's the original, just there. There we've done the tidying up. There's the grayscale. You can see the dark blues. Now we've lost, they've joined up there, but that's life. There's the grayscale levels, and there's the binary image. Now we're not going to end up with 5 separate ones, we're going to end up with 6, but what can you do? Just go back to here. Just pick it up there. Now in Brett's example, the original file size is bigger, and just to show you here, he was taking blobs of larger than 1400, but whatever the image I took from above was much smaller than the one he was working on, so I made it 100. There's no scientific way, it's just trial and error. Well, you could get very scientific, but there's a lot of work to automate it. So we did that. So the threshold value is 112. Again, he could have used Otsu's method to pick the threshold, but Brett just hardwired in a value of 112. That's 112 from 0 to 255. Larger than 100. And that's my binary image. So we only have the black and whites where the areas are bigger than 100. And then we fill it. So in case there's any little holes inside that, we fill that. And then on this line here, if by any chance there was anything touching the border, cells touching the border, we clear borders, so we're not including the cells that touch the border of the image. And we show that in 335, so that's 3 rows, 3 columns, number 5. 1, 2, 3, 4, 5. So we're showing it there. Now we're going to label, so we're going to label the objects. So just remind yourself again, that's, remember, you go along this way, so that is going to be, if I just super blow that up, won't blow for me, just 1 second. So that's going to be object 1. While we go out this way, drop down, that's the first one, that's going to be object 1, that's going to be object 2, that's going to be object 3, object 4, and object 5. Okay, just go back to the code. So we've just done that, and we've put on the axis, and we've put on the title, etc. The labeled, we've done that explain, which is the label, and then we're going to label the RGB. So we're just going to, those 5 objects, we're just going to apply random RGB colors, and we can see that in number 6. Let's go down a bit here. I have it so zoomed now I can't. Coming into scene here, 4, 5. And there's the pseudo random colors. There's, okay, just around there. Here we get the region prop, so we're using the old commands in MATLAB, so we're getting the, the area, the bounding boxes, the mean, the centroid, all that stuff. He's only picking up the area, but you could get all of them from region props, and then you're sorting them from smallest to biggest. Sorry, biggest to smallest. We're descending, so you get the biggest area to the smallest area. Now some more tidying up here. So what we want to do is we dilate the mask. So remember, dilating, you make the objects of interest are white, you make them slightly bigger. The mean gray level of the background, and then make the color channels the mean where the background is, so we can, sorry, here we are. So we're just there. This is in the published one. So we're getting the mean values. We dilated it. We made the background mask the inverse of it there. Remember, the tilde is the inverse. And we got the mean, and we get the mean of the background mask. We combine the 3 here again. Cat is concatenate. So you'll end up with a red layer in channel 1, are green in channel 2 or layer 2 and a blue in layer 3. And we see that in 337. So there's 337. There's 337. With the masked image. Okay. (337). Now we did the k-means classification. So there we are. So the number of colors is 3 now. Okay, and we run the k-means unsupervised classification there, and then we put our results into 8 and 9, and then we show the classification. So if we just go down here, there's 8, and there it is. Okay, so hope that helps a little. Thanks very much for listening.